Hello friends and welcome back, and today we will be discovering some Seaborn plots, and as you can see that we will go ahead and do this distribution plot with Seaborn. So let's understand what is the distribution plot. And as you can see, we can see here histogram and a KDE along with some vertical ticks here. So we'll explore all these things in this video. So what I do is we will work on a data set called exercise, which has been already there in the Seaborn. So what we'll do is we'll first of all work with this data set, and let's import the libraries, the basic libraries being the Seaborn as SNS, and I also import matplotlib dot pyplot as plt. And these two are the plotting libraries, Seaborn built upon matplotlib, so we will require matplotlib. Now in a data frame, what I'll do is I will create a data set from SNS. I will tell SNS.load data. I want to load the data set, and the data set is exercise which we are working with. So we'll take this exercise data set and let's check the first 5 entries of this data set, and we see that we've got something like this, right? ID, diet, pulse, time, and kind. And if you want to see the last 5 entries of a data set, just write this here, and you shall see this that you've got some in kind. You'll see running 15 minutes, 30 minutes, 1 minute, and so on. And in diet, you see that you've got low fat and no fat. Now, how many data is how many rows and columns are there? It will be estimated with df.shape, which will tell you the rows, 90 rows and 6 columns, and we see here 6 columns and the 90 rows, the index, right? Since 0 has also been included here, that's why it is counting as 90. Now we'll come to the plotting part of it, and let's just start with the distribution plot. So let's start with the distribution. It's called distribution or distplot. So it's called distribution, or it is also known as the distplots. And what I'll do is I will plot one, and then we shall see what else can we do with this distribution plots. So what you do is write distplot, and in your data frame, whatever you want to plot. So we'll go ahead and plot pulse, and let's take the color as purple, right? And let's plot this. So as you can see that this is the simplest plot of distribution plot, wherein you can see a histogram and a KDE. Now you see here that you on the x-axis you've got the pulse which I wanted to plot, and on the y-axis you've got this KDE, the frequencies plotted. Okay, now since it is a combination of two plots, a histogram and a KDE, you can do few more things here. Now to see attributes or parameters which you can pass, just press shift and tab, and you can see this signature, and you can just pass the hist is true and KDE is true by default. You can also pass rug here. So we shall discover all these things now and see what we can do further. You can pass color, which we have passed here. You can pass label, you can pass AX, and so on. So let's just see what else we can do. So what I do is I will again write here sns.distplot, and I will write here df, and let's take again pulse, right? And I will set the histogram as false, and let's take the color as red. So now what happened here is that it has set the histogram as false, and I'm only getting the KDE. Alright. Similarly, you can again do the same thing when you don't want KDE and you simply want a histogram. So what you'll do is just copy paste it here, and instead of hist, just write here KDE is false, and give it a good color, suppose green, and go ahead with it. So we see here the histogram. If you want to specify the bins, just specify the bins as 20 or so, and you will see the distribution, the entire range of your pulse, the data is being divided in this bin. And you can just, if you want to increase this bin, you can just increase it with 30, and you see that there's more clear visualization of your data with bins separated as 30, and it shows your entire range covering in this bin. So this is what you can see here. On x-axis you will see the pulse plotted, and on y you can see the number of observation, the count of it, and the height represents this number of count of frequency of its occurrence. So now you can see here that most of the data is lying between like around more than 80 to less than 110, and you can see little fluctuation here. So the shape of the data is not that uniform, but it just varies according to the kind of exercise we do. And since we have not explored this data set further, we are just exploring the pulse feature here. What if I want to plot here time? So will it plot? Let's see. What I do is I will again use this, and instead of pulse, let's take time, okay, and see what happens. So this has given me an error. Why has it given me an error? And it says that it cannot convert string to float 1 minute. That means it is a string and it is not an integer. So for that, let's just check our d types. So I will just go ahead and check my d types, and I see that yes, this time is a category and it is not an integer, whereas pulse is an integer. Okay, so if ID and unnamed, that means can be plotted because they are integers. So if what I do is I can just simply, instead of pulse, if I just write here ID, let's see what happens. Okay, right, so it has plotted this ID, and I would just see the distribution with KDE and histogram. Alright, so that means I come to a conclusion that the distribution plot numeric variables, and also they are univariate. That means they are plotting just one variable, they're showing only one variable, that too which is numeric in nature and not categorical variables. So what about when we see this and when we have to plot these categorical variables in Seaborn, what do we do? So this we shall discover in our next upcoming videos. Stay tuned. Thank you.